Hello everyone, welcome to Automobile Engineering class. I am Rakesh, Assistant Professor in Mechanical Engineering Department. In this session, I am going to explain power steering system. The power steering system is the system employed in automobiles to reduce the effort required to operate the steering wheel. This feature adds to the comfort while driving as less effort is required to turn the steering by the driver. An automobile steering system in which the engine's power is used to supplement the driver's effort in turning the steering wheel. The first power steering system on an automobile was apparently installed in 1876 by a man with the surname of Fitz. Next power steering system was put on a Columbia 5-ton truck in 1903. The power steering system is mainly important for the cars which have engine in front and there is a lot of weight on the front wheels. The power steering system incorporates a fail-safe design which allows manual steering to be done if the system develops some problem. So, in this case, more effort is required to steer the vehicle than the normal steering. Let us see the advantages of power steering system. The power steering system reduces the number of turns of steering wheel required to move it from lock to lock. That means the steering ratio on a vehicle having power steering is usually less. Easy steering while parking at low speeds or tight turns. Disadvantages: the components used in power steering assembly are more costly than the ones used in the normal steering. Let us see the types of power steering systems. The most commonly power steering systems employed in automobiles are: first one is hydraulic power steering systems, second one is electrically assisted electronic power steering systems or simply electronic power steering system, short form is EPS. The hydraulic power steering uses high pressure fluid for assisting the steering movement. When the driver turns the steering wheel, it opens up the flow of pressurized fluid in such a way that helps to turn the wheels in required direction. The hydraulic power steering is a technology used for decades and has improved a lot with time. Earlier, it did not have any difference in steering response with speed of the car, but the new type of hydraulic power steering systems are speed sensitive and work better than the older hydraulic power steering. When the vehicle is moving slowly, the degree of steering assistance is made higher to provide light steering action. When the vehicle is moving at high speeds, the degree of steering assistance is made relatively low to provide stiffer steering motion. This system having a hydraulic booster that reduces the force required to operate the steering wheel. Second one is electronic power steering system. When the front wheels are in the straight ahead position and no force is applied on the steering wheel, electronic power steering system, it works with the help of an electric motor and a control unit which has some sensors. The motor runs on battery and will use electric power to assist the movement of steering when the driver turns the wheel. The electric power steering is comparatively a new technology with less complicated structure and mechanism that takes less space and is more durable. The electric power steering the electric power steering use sensors like torque sensor, rotation sensor to these sensors to sense the car speed and will take care of the different steering response required for different speeds. Let us brief discussing about hydraulic power steering system. Okay, let us see this figure. It consists of pump, power cylinder, control valve, reservoir. The function of pump is it generates hydraulic pressure. The function of control valve is it switches the oil passage to the power cylinder according to the rotational direction of the steering wheel. The function of power cylinder is in this uh, the piston moves in the cylinder to the right or left with hydraulic force and thereby assist the steering wheel operation. This power cylinder is divided into two parts. One is chamber A and chamber B. Next one is fluid reservoir. The power steering fluid reservoir stores the fluid and cleans it using a built-in filter. When the steering wheel is turned counterclockwise or clockwise, hydraulic pressure from the pump is shifted by the control valve and drawn into the cylinder uh, left or right left or right chamber. The power cylinder In the power cylinder, piston is moved by the hydraulic pressure to the left. This assists the steering wheel operation and thereby steering wheel can be operated with a light force. The hydraulic steering system are generally divided in two types. One is linkage type hydraulic power steering system. Second one is integral type hydraulic power steering system. Okay. In this system, in linkage type system uses a separate hydraulic power cylinder controlled by a valve assembly attached to the drop arm to assist in steering. In integral type, power steering system has the power cylinder and the control valve as integral part of the steering system. These both systems like that is linkage type and integral type of power steering systems require an oil pump to supply oil under pressure to operate the hydraulic cylinder when the steering wheel is turned. This oil pump is driven by a belt attached to the crankshaft. Later discussing about linkage type hydraulic power steering system. This type of steering system includes a fluid reservoir and pump, a control valve which is a spool valve type control valve, a power cylinder. These are the connecting fluid lines and the necessary steering linkages. The hydraulic pump is uh, belt driven from the engine crankshaft and provides fluid pressure for the system. A pressure relief valve, also known as flow control valves, is incorporated in the pump and is used to govern the pressures within the system according to the varying condition of operation. The fluid in the system returns to the reservoir after it circulates from the pump to the control valve and power cylinder. The control valve is operated by the movement of the steering wheel and supply the fluids to the power cylinder by switching the oil passage according to the rotation of the steering. Let us see the different conditions of operations. First one is when the steering wheel is not operated, that means the steering wheel is in neutral position. In this in this case, when the front wheels are in straight head position and no force is applied on the steering wheel, the spool valve is held in the central position by its centering spring. The fluid flows the fluid flows around the valve area and returns to the reservoir. Second case is when the steering wheel is operated. When the steering is turned clockwise, that means rotate in right side, the spool valve interconnected to the steering wheel overcome the force of centering spring and moves to the left of the valve. The fluid from the pump flows through the passage P to the chamber B of the power cylinder. The fluid in the chamber is discharged by piston and returns to the reservoir. When the force on the steering wheel falls below the set limits, the spool valve centering spring forces the spool back to the center position. This causes pressure on both sides of the power cylinder piston to become equal. In the absence of operating pressure within the power cylinder, the front wheel tends to return to the straight ahead position due to steering geometry and wheel alignment. When the steering wheel is turned counterclockwise, that means left side, in this case, the fluid enter into the chamber A and discharge from chamber B to the reservoir. Second one is integral type hydraulic power steering system. This type of steering system includes a fluid reservoir and a pump. The pump is connected to the This pump is connected by the flexible hydraulic lines to a power cylinder that, along with control valve, is an integral part of the steering gear. In this, the control valve in the system is a rotary type and is located in the upper section of the gear housing. The rotary valve The rotary valve type power steering system are relatively simple in construction and of compact size. It consists of input shaft, a torsion bar, and a valve. All of these are mounted in a coaxial manner. The valve unit consists of the following two sections. One is uh, steering wheel and input shaft. Second one is pinion shaft, and valve. One section is steering wheel and input shaft. Second one is valve and pinion shaft. The input shaft and the pinion shaft, in case of rack and pinion type steering gear mechanism, these two types, that is input shaft and pinion shaft, are each connected to an opposing end of the torsion bar. See here, this wall is mounted over the input shaft and is connected with pinion shaft through a pin. When the steering wheel is turned, the torsion bar twists and causes the input shaft and valve to rotate with the steering wheel. The relative position of the valve and input shaft is changed in position to this twisting. The flow of fluid and pressure is controlled in accordance with this motion and directed to the proper side of power cylinder to assist the turning action. The different conditions of operations are discussing in the next slide. First one is when the steering wheel is not operated, that means neutral position. When the front wheels are in the stated position and no force is applied on the steering wheel, the input shaft is in the neutral position. See this left side figure. Uh, this is this center circle is called torsion bar. This is the valve. This is the input shaft. This is the power cylinder. When the front wheels are in the stated position and no force is applied in the steering wheel, the input shaft is neutral, and the fluid from the pump return to the reservoir through a rotary valve. In straight ahead position, the pressure on both sides of piston is equal. Therefore, it does not move. The fluid acts as a cushion to absorb the shocks, so they are not uh, transferred to steering wheel. Second condition is when the steering wheel is operated. Uh, in this case, when the steering wheel is turned counterclockwise, that means left side, the input shaft will also turn. The input shaft also turn in the same direction. The torsion bar is twisted and creates a gap between the input shaft and valve. The fluid from the pump, now flows through the rotary valve into a chamber A of the power cylinder and increase the pressure on the power cylinder piston, forcing it to move right. This provides assistance for steering wheel operation. At the same time, the return passage from the power cylinder, that means chamber B, opens. This forces the fluid out through the valve and back to the reservoir. When the turning effort is removed, when the turning effort is removed from the steering wheel, the torsion bar untwists. uh, returning the valve to a straight ahead position. The oil pressure then becomes equal on both sides of the power cylinder and no further assist is present. The front wheels return to the straight ahead position due to the steering geometry and wheel alignment. When the steering wheel is turned in clockwise direction, that means right side. In this case, the fluid from the pump to the uh, enter in the chamber B and release discharge from chamber A to the reservoir. This is the brief discussion about hydraulic power steering systems. Next one is electronic power steering system. The basic operating principle of electronic power steering system is same as hydraulic power steering except the following component changes. In this we are using torque sensor, electric motor and EPS control unit. The torque sensor is used in the place of valve body unit. The electric motor is used in the place of hydraulic power cylinder. The EPS control unit is added in electronic power steering system. It consists of the following parts. This is the rack and pinion mechanism. This is the input shaft. This is the torque sensor. This one is the EPS control unit. EPS control unit consists of speed sensor and rotation sensor. This is the motor. This is the recirculating ball screws. The electronic power steering system consists of a rack and pinion steering gear with an electric motor installed around the rack which supply the power. In this we are using DC motor. The rack shaft passes through the motor armature and is held by recirculating uh, ball screw. The motor transmits its power to push the rack right or left direction. A steering sensor is installed on the input shaft. See here, this is the input shaft. That means it is also called a pinion shaft, which is actually made up of two sensors. One is torque sensor, another one is rotation sensor. The torque sensor converts the steering torque input to the torque sensor converts steering torque input and its direction into the voltage signals, and a rotation sensor converts the rotation speed and direction into the voltage signals. The input from the steering sensor are processed by a microprocessor based control unit, that is EPS, electronic control unit or EPS ECU, that also monitors the input from the vehicle speed sensor. The sensor inputs are then compared to determine how much power is required according to a pre-programmed force map in the control unit's memory. The control unit then send out the appropriate command to the inbuilt power until which then supply the electric motor with current. The motor pushes the rack to the right or left side depending on which way the current flows. That means reversing the current reverse the direction of the motor spin or rotation. If the steering wheel is turned and held in the full lock position and steering reaches a maximum, the control unit reduces the current. The control unit reduces the current to the electric motor to prevent an overload situation that might damage the motor. The control unit is also designed to protect the motor against the voltage surges from a faulty alternator or charging problems. The EPS system has a fail-safe control to ensure safety in the event of a fault in the EPS system. The EPS control unit monitors signals, the motor's operation and its own operation. If the EPS control unit detects any abnormality, it illuminates the warning light, and depending on the nature of abnormality, keep the EPS system operating as normal as possible. It is not possible to continue the operation of EPS. Motor assistance is terminated and the vehicle is steered manually. Let us see the advantages of electronic power steering system. It is compact, light and quiet in operation. It consumes power from the battery which is also being charged by the engine. Thus, vehicle fuel mileage is increased. It also provides precise control at different speeds. It requires less maintenance as there are no hydraulic lines to brake. This is the brief discussion about hydraulic power steering system and electronic power steering system. Thank you for watching. Please do like and subscribe my channel for more updates.